Okay, so then welcome to our new seminar, the invited lab talks that we organize at the Institute of Computer Graphics every month. And we need to turn off your speaker. My name is Oliver Wimmer. I'm heading the institute. We have today Mohammed Abbass. He is here since a couple of months already now, coming from Cairo. He's here as a senior lecturer for 5 years. So some of you might know him from courses in AI that he organizes. But he's also already an assistant professor. He comes from Cairo. Was the assistant professor in Cairo, which is PhD, his master and bachelor in Egypt, and his PhD in South Korea, as far as I remember. And he is interested in several AI-related topics, including text-to-linguistic use. And that's what he's going to talk about today.
Okay. Thanks, Oliver. I appreciate your kind introduction. Hello, everyone. Today's topic is text to realistic image synthesis. Just briefly, I will introduce myself and my life profile. I finished my master's degree in 2014, and I earned my PhD in 2021. And in the same year, I got a postdoc at M.Sc University, and I got promoted for assistant professor in my previous institute. And then I joined remotely Malta University for a postdoc as well. And 2 months back, I joined JKU. I would prefer to introduce some previous work and some previous results, and then I can start my talk. 4 or 5 years back, I started this topic, which is image tracking. Because I got engaged to one project, which was autonomous vehicle. So as we can see, this image tracking has several challenges. The idea is, if we have desired object, so the goal is to draw one precise bounding box around the object. And we just keep moving this bounding box on that object. Unfortunately, it is not easy task due to several challenges. For example, now that guy, we are tracking the face of that guy. So since that guy is celebrating, is cheering, so the appearance is changing. And as we know, every thing now is moving. For example, like camera is moving, object is moving, so we don't have any stationary items or any stationary thing. So we need to also cover that. So we may have a blurring image. We may have the appearance could be changing and varying from frame to frame. Also, the light condition is changing from frame to frame as well. Sometimes, as we can see here, the object or our required object can get occluded, either fully occluded or partially occluded by another undesired object. And as we can see also, the background could be cluttered or crowded. So due to those challenges, I started that topic, and I designed one algorithm. And that algorithm was based on deep learning model. I utilized correlation filter. It is very popular algorithm for tracking. But first step, I utilized VGG19 to extract several feature maps. And based on those feature maps, I feed them to correlation filter to calculate what is the best position in coming frames. And I got good results, and I published in that journal, which is Visual Computer, which is belonging to Springer, and it has an impact factor 2.8. And I compared my results with 10 published algorithms, and I did several experiments as well. I utilized OTB benchmark, which has several challenges. And as we can see here, either my precision and my success rate is a bit higher than the published previous algorithms. And after that, I extended my work and I got another results, and I published those results in another journal, which is Artificial Intelligence Review, which is also belonging to Springer and has an impact factor 6.5. After that, I tried to collect real data. So one guy, when I was in Korea, helped me to collect those data. He had one camera in his car, and he has black box. So he gave me several videos. So for example, this is real video from his car, and I applied my algorithm. So just I stopped at the general data and published a data set, but I collected several data from my colleagues, but I didn't pursue this point. So this point or this research direction, hopefully I can pursue it. I started to collect, as I mentioned, several data, and I tried to detect new objects to track them. So the idea, I was working on autonomous vehicle. So the idea, I have to detect the surrounding either vehicles or surrounding pedestrians. And after detection, I need to track them. And I need also to cover or to solve several issues, as I mentioned, like occlusion or blurry, if we have like blurring image, light condition. So I started apply several detections. Even also, I started to collect several data from severe environments. I have data like, for example, like I have one video, the car is moving to tunnel. So as we know, like the light condition before tunnel is different than after tunnel. So also I collected those data. Unfortunately, I didn't pursue so far that points. And also I have a great intention to utilize several cameras and LiDAR and several sensors and collect all those data in one algorithm. And as well, since I was working on vehicle tracking and autonomous vehicle, also I have to detect lanes to keep the vehicle inside that lane. After that, I moved to another topic, which is super resolution. That topic is many researchers are utilizing this topic. The idea is very simple. So suppose we have M by N image. So we need to scale up this image by certain factor, like for example, like by 2. So for example, if we have 100 rows and 100 columns, and we need to scale up by 2, so we need to map that image from 100 by 100 to 200 to 200. So also I designed one flow chart. I proposed one flow chart, one algorithm. In that algorithm, I changed the RGB channels to YUV channels. The intuition behind that is, so since most of information can be considered in a Y channel. So to speed up my algorithm, I utilized bicubic algorithm. It's very simple to scale up U and V channels, and based on the deep learning, I can magnify and I can scale up the Y channel. And I used a guided filter as well to enhance the edges. And after I scale up, I can also get back the RGB image. So I proposed this algorithm, these steps, and I utilized the idea of residual dense to prevent vanishing points. So as we know, we have issue which is vanishing points. So we can solve it by residual dense block algorithm. Although that algorithm got published in that paper, which is multimedia tools and application, which is also belonging to Springer, and it has an impact factor 2.5. And in that paper, I compared with 8 published methods, and also I did several experiments using 4 different data sets. One year back, I started one new topic. So far, I didn't publish in that topic, but I started that topic. The reason why I started that topic because I had discussion before with my friend. That friend told me we had like accident in one building, and unfortunately several people died in that building because they didn't run out or they didn't leave that building. So the idea to utilize this sign, exit sign. So since this exit sign like got scattered in everywhere in the building, so we can embed very small cameras, and we can detect either fire or smoke or even like persons. I mean, for example, like if we have fire in certain floor, so we can using this sign, exit sign, to embed very small cameras to detect people. So if we have anyone got faint, for example, so we can detect that person, and we can order our priority. So okay, we have fire in floor 2, and we have faint person in that floor, so we can go directly to that floor. So that's why I am targeting very low power algorithm, and to save like either power and processing time. And also so far I am working on attention mechanism. So far I don't have good results to publish, but I am working on it, but I am showing my future direction. So let's move to our talk. So since everyone knows about ChatGPT, so the idea is, so just you can write any text in ChatGPT, and the ChatGPT is giving text description. So in the same manner, so if I have text description, how I can convert this text to image? For example, now I am writing a boy and dog are playing. So is it possible to get that image, to build one model, and that model should be able to generate that image? Nowadays, yes, we can have, and we can do that. But we need to consider like 2 points. The first one, in that sentence, we have like 2 or 3 objects, like boy, dog, football. So we need to consider several objects, and we need to consider also they are playing. For example, they are not fighting. So also we have to consider the words. So we have to consider several items here. And several researchers started working on that topic, which is like from text to image description. So for example, like guys from NVIDIA, they started publishing one algorithm, which is face generation. So as we can see here, no face here is real. So all those faces are fake. So the idea here as well, so how we can generate one face and how we can change and manipulate that face. For example, if we have, or if we describe one guy with like a mustache, with glasses, with beard, so how can I manipulate, or how can I change that generated face to another face, which could be like a girl or any another face? For example, like in this first column, we generated one face, but we manipulate this face to another face, where like to look like this girl. So this girl has certain like hair style. So how we can manipulate between different faces. So in order to do that, we can use GAN. So let's start with GAN and just see the terminology. So GAN stands for Generative Adversarial Network. So let's start with generative. So generative means we need to generate data, fake data, either image or text. Adversarial means we have 2 guys are competing. So here we have 2 networks. So every network is competing with another network. So the generator here is trying to fool the discriminator. The generator is trying to generate fake data and fool the network, to fool the discriminator, which the discriminator also is trying to distinguish between fake image, for example, or fake or real image. And networks, so here we can have either neural network or deep learning, and the DC GAN, which is deep convolutional GAN, is very popular one. And we can see GAN in several applications as well. For example, in data augmentation, also several researchers, as we know, to train your deep learning model, you have to have sufficient data. Some applications, we don't have sufficient data. So in order to increase our data set, we can use GAN to generate fake data, which is not existing. So we can use GAN to generate, to increase your data set. Also, you can use GAN in super resolution. Also, several researchers are using GAN to construct 3D images. And from image to image translation as well, we can use GAN. And as I mentioned, we can use GAN to generate faces. For example, we have site here, which is this person doesn't exist. For example, this pretty face actually is not existing. It is fake face. Just you can set some parameters and that site can generate that face. And they are using GAN. So just let's see how GAN is working. So as I mentioned, we have two networks. The first network is a generator, and the second one is discriminator. So the input of generator is random noise. So the idea is we need to feed random noise to the generator, and the generator should convert this noise to fake images. And after that, we need to feed real images and fake images to discriminator network, and the discriminator should be able to distinguish between real and fake images. After that, we need to improve the loss, either in generator or discriminator. Here, for example, so if we wanna generate cat image, okay, so in the first epochs, the generator is trying to convert the noise to cat image, but the first epochs, the generator shouldn't be able to do that. Okay, so the discriminator should be able to distinguish, okay, this is not cat. After several epochs, the generator should be more able to generate at least skeleton for cat or layout for cat, but still the discriminator can say, okay, no, it's not cat. The discriminator can distinguish the fake images. But after several epochs, the generator should be able to generate fake cat, but it should look a very real image. At that time, the discriminator cannot distinguish, okay, I mean, the discriminator can say, okay, this 50% fake or this image 50% real. At that time, we can stop the training because the discriminator cannot distinguish, is it fake or real. So to the steps to train, so we have two networks, discriminator and generator. So we have to do some steps to train both networks. So the first step, we have to design and we have to define our both networks, generator network and discriminator network. Because sometimes if we work on certain application and if we are utilizing certain generator network, so sometimes we cannot utilize it in another application. So you have to define your generator network and discriminator network as well. After that, we need to start to generate fake data using a generator network. After that, we concatenate the generated fake data with real data to concatenate both and feed them to the discriminator. And the crucial point here, we have to train one network at the time. I mean, we cannot train discriminator and generator simultaneously. Just we can train one network in certain time. We start with the generator, so we keep all values in discriminator constant. And after we start training the discriminator, we need to keep all values in generator fixed. So here, as I mentioned, we should start with generator to generate fake data, and after that we, for example, if we say batch size is 32, so we can generate 16 fake images, and we can concatenate those images with another fake. With another real images, so we generated fake images, and we can concatenate with other real images and feed those images to the discriminator. And also we need to label them to calculate the loss. So in the first epochs, the discriminator should be able to distinguish between them, real images and fake images. But after several epochs, the discriminator cannot distinguish between them. So now we are talking about loss. So since we have generator and discriminator, so in discriminator part, we need to maximize the loss. Okay, so the generator wants to maximize the loss values for discriminator, but discriminator wants to have the discriminator wants to get very, very low loss. Okay, so in order to do that, we have two parts. The first part is belonging to real images, and the second part is belonging to fake images. So suppose now we have real image. So here the probability to say, okay, this real is 1. Okay, so the log 1 is 0, so the loss is 0. So if we have fake data, so the discriminator should be able to say, okay, this fake data, which means it is 0. So also 1 minus 0 gives 1, which, and the log 1 is 0. So the loss for discriminator here is 0, which is minimum. But the generator doesn't want this case. Okay. So let's have another example. So suppose now we have a batch size, which is 32 images. We have 16 real images and 16 fake images. For simplicity, we can say, okay, the probability for real images is 0.9 and the probability for fake image is 0.2. So if we substitute those probability in our equation, so the log 0.9 is giving 0.05, and the log for real images is giving 0.223. So now we have the probabilities for real images and for fake images. Now we are able to calculate the expectation and the total loss. So the total loss is 0.164. Okay. So as I mentioned, so this is the case for discriminator, but actually the generator are looking for opposite direction, which means the generator wants to maximize the total loss for discriminator. So the best case for generator is if we have fake data, so discriminator should give a very high maximum number we can have is 1. So the probability should be high. So the generator wants that case. So because in that case we have very fake image, but it look real image. Okay. So in that case, if we have like high probability for fake image, but it looks like real, so we have high probability here. So the total loss here is maximum, -1. So negative is representing loss, and 1 is the maximum value we can reach. I started one algorithm, but I am evaluating it. I didn't finish it, and I made tiny modification as well. So far I am using from 3 to 4 networks. Why from 3 to 4 networks? Three discriminator and 3 generator. And I may use 4 generator and 4 discriminator as well, because I am generating image from scratch. So I cannot have a very high resolution image in one step. So I need to start from 32 to 32 resolution. So one network should give that resolution, and after that, I have to feed that resolution, which is 32 by 32, to another network to produce 64 by 64, and another network should produce 128 by 128, and so on. So I can scale up the resolution by consecutive networks. So I need to train from 3 to 4 generator and discriminator networks to reach like 128 by 128 resolution image. And also, as I mentioned in the beginning, I am utilizing attention network because in our text, we can have several words. For example, like dog, boy, football, playing. So we need to extract those words to help our model to distinguish between those. So for example, as I said, like playing or fighting, like boy or like man or guy. So we need to distinguish between different words. So here I am utilizing attention mechanism to distinguish between different words. And also to manipulate between different shapes. Also, I am utilizing control gain. For example, if I have one guy without mustache, for example, or without glasses, so I can manipulate the generated one to remove or to add mustache or beard, for example. So far, I am utilizing 2 databases. The first one is CUB and the second one is Cuckoo. And since I am using text to image, also I have to consider this total loss. Here we have 2 losses. The first loss is image. I need to distinguish between, okay, this image is real or fake. So this one loss. And another loss is description. For example, okay, I can describe, I want to generate guy, for example. So, and the network, okay, generated one picture, which is girl, and this girl is looking like very real girl. So, but unfortunately, I texted guy. So now this generated image is not matching with the text. So we have 2 losses. One loss is responsible for image itself, and another loss is responsible for text itself. For example, here it's like one example. I in the database. So we have bird here, and we have certain description. So we can have, if you look to that database, you can find, I guess, like more than like 1,000 images and description. Just I picked 2 examples here. So as I mentioned, I started training one algorithm. I started training that algorithm like more than 2 months back. I did some ebooks when I was in Egypt, and I did here also several ebooks. So far, I didn't finish the whole training. Just I finished even less than 30% of training, because I am training 3 networks, like 6 networks, like 3 networks for generator and 3 other networks for discriminator. So as we can see here in the first ebooks, so this one is real one, but this one or generator is trying to create bird which is like close to that one. So this one is at the first ebooks, and after several ebooks, so we have, yes, some improved image here. Still, I didn't finish, but still, as we can see, For example, here we have like this bird has like yellow, so the generator is able to generate yellow spots or patches at the bird. So hopefully, after I finish the training, hopefully I can see how can I modify more, how can I enhance more. Yeah, that's it.
So those people online probably have noticed that I made a mistake. I shared the presentation screen and not the big screen, but I think we still saw the slides. Yeah, so this would be now time for questions. Do you have questions?
So thank you for first of all.
Yeah, thanks.
So sorry if I missed this, but do you know about the literature behind using generative models as a source to train other models? Because I would think that clearly you would just learn the distribution that the generative model is learned, not the real distribution, and this might introduce certain problems to know the literature behind this.
Yeah, actually, if we have one like distribution data, so the generative or the generator model is trying to map the data noise to that distribution data. So your question is, what's the goal of that?
Well, the question is, you have a model that tries to learn a real life distribution, but it's not going to be able to sense the real life.
Yes, right.
And now you're tracing from a distribution that has distribution shifts, that is the downside, and the upside is you can generate as many samples as you want. And what is like the problem with that? Is this even a problem?
Yeah, it could be issue. But some, for example, like in some applications, for example, in 3D reconstruction or in super resolution, some details you can generate. I mean, like if we have like generated some fake parts from super resolution, it cannot affect the whole image. Yeah, could be.
Any more questions also from people online? You just have to unmute yourself and ask. Use the chat.
I would have a question regarding the discriminator. How I didn't quite understand how you would define the discriminator. So basically, it would also be a detector for the object that the generator is generating, but judging how well the object is presented.
Yeah, so it's correct. So in the beginning, actually, like in the beginning, we need to generate some fake data, and based on that data, we need also to train the discriminator part. So in that point, the discriminator should be able to distinguish between them. I mean, we are not just generating fake data. That's it. No, just we need to generate also those data with real data to the discriminator, and the discriminator is should be able to distinguish between real and fake data. For example, if we are using image, so the discriminator should be able to distinguish between them, because otherwise, if we are not improving the discriminator, which means the generator cannot also generate very good fake data. For example, like, okay, after several epochs, like after 10 epochs, the generator can generate faces, for example. But if we are not training and improving the discriminator, the training will stop at that point. So we couldn't have very real, like fake images, but should be look like real image. Yeah, so we need to improve as well the discriminator in order to improve the generator. Yeah.
Yes.
Okay, more questions? Online? So you were talking about text to image conversion.
Yes.
You know anything about the opposite direction? So for example, for faces, we need some text description to produce the faces, the images of the faces, but I don't know, you know which descriptions make good faces, and would it be possible to do the other way around? You have an image of a face and you get maybe the description that suits that.
Yeah, I didn't think about that. I didn't think about that. The intuition to convert like text to image, we have like several cases. For example, also like in the like if we have like crime or anything, so you can easily describe the face, right? So if we have good models, so the model can convert this description to image.
Yeah, but I was wondering, what is a good description? So what are the good keywords that give you the correct face? And if you do it the other way around by having a face and get the keywords, you maybe get an idea about what is a good description that makes up a proper face.
Yeah, also it is a challenge board. So that's why I am using attention mechanism to pay more attention to some words. For example, if I am describing one guy, so for example, that guy has a mustache or beard or is wearing glasses, or I am describing one girl who has certain hairstyle. So so that's why I'm focusing on attention mechanism to pay more attention to some keywords to generate image which is matching with that text. Yeah, it is very, it's very challenge points. Yeah.
How do you calculate the loss for that? So if in the image the voice really plain, how do you calculate that loss? If you write the word plain, that you know in the image there's also the plain.
Image plane, what do you mean?
Yeah, I mean, if you say there's a boy and a girl, how do you know that if in the image there's really a boy and a girl? How do you know calculate the loss?
Yeah. So actually, as I showed here, so we have database. So for example, we have image and description. So we know the image and we know the description. So in the first step, we need to generate some images from generator using some noise data and feed the generated image and the description to the discriminator. So we know the description and we know the image. And the discriminator should distinguish, okay, this image is real or fake. For example, it's fake image, but the discriminator says, okay, it is real image. So this, we need to calculate the loss in this part. And in this part also, we need to calculate the loss for text as well. Because as you said, okay, I may describe girl, but the image is boy. So I need two losses, one for image and one for description. But in the database, we have both. We have ground truth for images and description. So we know the text and we know the image. So we can calculate the loss.
So you compare it with images where you know there is.
Yes, exactly. Yes. For example, this one is ground truth, is our data set, and this one is coming from generator. Okay. So for example, if the discriminator says, okay, this one is very real image. Okay. So in that step, okay, we did good job because the generator is able to generate very, very big image, which is looking a real one. But we know the data, the ground truth, and we know the generated one. In that case, we can calculate the loss.
Okay, more questions? Anyone online?
In this we have one. Yeah, so we have one good question here. One is asking about like consecutive networks. So as I mentioned, we are generating image from scratch. So we cannot generate image with high resolution. So we start with very low resolution and we scale up using consecutive networks. So he is asking about that. So every time, I mean, like suppose we have like network 1, 2, 3. So every time we are embed the text to that network, yes, we have to embed. For example, we have 3 consecutive networks. We should start train the first network. So we need to calculate the loss. And we need to embed the text and the image and calculate the loss in terms of regarding the image and the text. After we train the first network, we have to move to next one, and we need to embed also as well the text and the image as well. And after we finish the second network, we need to embed also the text to third network and the images as well. There's one more, maybe this was about the fire detection. Yeah. Yeah, I didn't think about that. Maybe you have to read the questions so everybody. Yeah. So in the project of detecting flames within a building, did you also think about the trolley problem? Since this influences whose saving is more important. Well, the question is, what is the trolley problem? Yeah, what the trolley problem? Yeah. Okay, the rest was a discussion on attendance with video presence here. I think that's not so important for you. If there's no more question from your side, we don't know what the trolley problem is, or that. Yeah, I don't know as well. If there's no more question from your side and also not from online, then I would suggest we thank you once more again. Thank you. And for those of you, is anybody here from a seminar student? We need to come to me to sign, right? Or at least to give me your names. Because
the problem is when we're in autonomous vehicle, drives left or right, and kills the left group, people on the right group.
Okay, but that was about the fire detection.
Yeah, I don't know why it's really not the big probably because of the car, like the image detection we had, start with the car. Because the trolley problem, I think, it's basically you can either choose to pull a lever and have a trolley kill a smaller number of people, or to not act and not pull the lever and have the trolley running on the tracks.
That was then in the context of the fire detection.
In the fire detection, we in the buildings, so we don't have trolley in the buildings.
No, but I think it was like in a similar sense when when you detect fires. Okay.
Trolley problem.
We did the decision whether to save more people about it.
But this was about fire detection, not about the decision on who to save. It was whatever, on smoke and fire detection. It's probably maybe out of the context. Okay, I think we would conclude this presentation for now. And those of you who are in the seminar, just let me know the names. And the next talk will be on the 16th of May at 11. It's, I think, on Moodle already, and it will be announced on our website. If you want to attend, by Fabian Beck and Shivan Akrawal from University of Bamberg. And this is a talk on from dynamic graphicization to visual games. So I guess it will be a mixture of visualization in computing. So I hope to see you there again. Thanks.